view of the world today is that you've got these giant mega corporations building data centers that are consuming all the power in the world just so they can train an enormous model using all of your information to put you out of a job. And this is true for individuals, it's true for large businesses, it's true for small businesses. So let's look at what if you don't want to do this anymore? What if you want to build your own? Start with a GPU. You might have a consumer GPU under your desk that you use for gaming. You may be a big company that's bought a bunch of these things from Jensen. That's the starting point. Welcome, humans. Today, let's figure out how to build your own language models rather than just using your favorites from Claude and OpenAI. Claude Shannon's great work on language models gave us large language models, together with scaling laws and GPUs. They're really useful, but I care about my private data. I care about my IP. And so I want some of my requests about general purpose things to go to Claude or OpenAI, but I want the things that I build and my personal information to be in my own model that I own and that I run. So you can log into a machine with your GPU set up, and you can clone Scalar LM. Okay, next we can do a Scalar LM deployment. We have some Helm charts that are built into Scalar LM. Once your Scalar LM deployment is up, you should get the UI. It should look like this, and you should be able to talk to it. In this video, I'm running this Gemma 4 model. Now you can chat with it, and when you chat with it, it produces training data. The key ingredient to being able to build your own models is getting data that can power them. I built a coding tool called Orbital. Let's go through and try out Orbital. So I can log in. I already have a pod running. Let me launch another one. So Orbital is going to launch a virtual computer, and it's going to directly connect to my Scalar LM deployment. All right, now my pod is running. Let's log in. You can directly SSH to it, or you can just press the web browser button. All right, so now this is a regular Unix machine. I'm going to run OpenCode. This is a coding agent. You can use any coding agent you want. The main point is to build so that you exercise the model and you use tokens. The agony of defeat. All right, after you've gotten our project build, let's go and look at sessions. So sessions is going to be all of the training data. So let's download it. These are all of the interactions that I've had with the LLM while I'm building. Download. I downloaded it. Okay, so now I need to convert this into a training data set. For this, I'm going to use evolve. So I just run evolve pipeline, and evolve pipeline is going to turn it into a training data set. And I already have one prepared. So in this one, I have some data. And this data set is going to include my interactions with the model, and it's going to have the ones where it actually learned something, where the model made a mistake, and then either by retrying or by communicating with the user, the model eventually got to a better answer. So these are traces that are going to improve the model on exactly the type of software that you're building. So now I have this data set. Now I'm going to submit a training job to Scalar LM. So here I load my data set and I submit a training job. And when I run the script, it launches the training job on Scalar LM. So this job represents the model we were just looking at. And we can visualize that the loss is going down. And we can see some of the data examples that we used to train. Now let's look at metrics. So here, I'm going to look at some standard evals, the regular LLM evals, like MMLU, Truthful QA, and I also have a new eval that was generated by this tool to cover the sessions that I was using to program against this model. So let's see how it works. Let's look at MMLU. So the base model got 85. This post-train model got 88. What you're looking for here is that the model is about the same on these general purpose metrics. It might be a little better, it might be a little worse. You want it to still be a good general purpose language model. Let's look at our new metric. So the new metric went from 32% of the tasks, the coding task completed in the base model on the first shot, to 62% completed in the first shot. So this model got substantially better at writing the types of programs that I've been using in my orbital sessions. Finally, once I've got a model that I like, I can publish it to Hugging Face. I can also talk to this model. One of the nice things about Scalar LM is that it lets you run models while they're being trained. So this model, as it's being trained, gets immediately deployed. And as it goes, it'll keep getting better. This model isn't fully converged yet, but I could also talk to another one like this one that's fully converged. And once I like it, I can publish the model to Hugging Face. You can also merge the model back together into a full model, publish it to your Hugging Face repo. So right now, if you don't want to go through all of this, we have enough capacity reserved to handle about 100 users on Orbital. And we can build the models for you and send them to you.